All right, gram to gram. So if we're doing grams to grams, then we are going to start with the grams of a substance. We got to get to moles of that substance so we can use the mole ratio in the chemical equation to then convert to moles of another substance. And then we take the moles of that substance and go to grams of that substance. Okay? Grams to moles, moles to moles, moles back to grams. All right? Okay. So, this is the same number from the last problem. So we're starting with the grams that's identical to the last problem. Now we just want to get to grams of the carbonate and grams of the carbon dioxide. So we can just go back and take what we've got from these steps, because it's the same here. Work smart, not hard. Copy, paste, paste. All right. So what we're doing is we're taking that 8.65 grams and we're using the molar mass that we calculated to get to moles, right, of copper oxide. Then we're using the mole ratio to get to moles of our product carbon. We're doing the same thing here for carbon dioxide. We've got to moles of carbon dioxide. But we don't stop there. The only difference now is we take it one step further. We don't want moles because we can't weigh that out in the lab. We need to get that now to grams of our substance. We say, okay, let's cancel out our copper oxides. All right, we're left with moles of carbon. I need to now get the moles of carbon to grams of carbon. So we know that moles of carbon needs to go on the bottom. I know that moles of carbon dioxide needs to go on the bottom. And that if I want grams, I need grams of carbon on top. If I want grams, I need grams of CO2 on top. Does this look familiar? Well, it should, because this is the same thing we did 2 problems back. Right here, in this step, right? This was the mole to gram step, right? So we need 12.011. Our atomic mass is our conversion factor for carbon, and we need 44.0099 for CO2. Right? These are just from the periodic table, right? Of course, we had to do some addition for this one, 44.0099, right? So now, those cancel out. And we'll be left with our answers in grams. So, do the math for the top one. 18.65 divided by 79.5454 divided by 2 times 12.0111. Now we want this to 4 sig figs. So this is going to be 1.408 grams of carbon. And the bottom one, it will be different. Why? Because carbon dioxide has a different mass than carbon, okay? 18.65 divided by 79.545 divided by 2 times 44.0099. This one is 5.159 grams of CO2. And there you go. A gram to gram problem. Now I know exactly how many grams to weigh out for carbon. Again, given the actual grams of copper oxide. This is the actual realistic scenario that you would be doing in a lab, right? Because you're actually going to weigh out your copper oxide. You would have obtained this many grams of copper oxide, and you would most likely just use this equation right here to go straight from copper oxide in grams all the way to grams of carbon in one simple step, right? And so you've gone straight from the grams of this right to the grams of this, and now you can just do your reaction right away with one simple equation, one simple process. And then with another simple process, predict exactly how many grams of carbon dioxide you've made. So gram-to-gram problems are more likely for the ones that you're going to be using if you're working in a lab.